Picture a car with glowing lights dancing across its body, a pickup truck that you can quickly change to a family SUV, or even a family-friendly mobile living room that takes you to your destination while you relax like you would at home. It sounds far-fetched, but these are real designs emerging today. In China especially, new electric automakers are unleashing vehicles that defy everything we thought a car should look like. From futuristic luxury sedans that resemble spaceships to cute microcars decorated in cartoon themes, the world's largest auto market is brimming with creativity. This wave of unconventional, surprising, even bizarre designs has many asking, is this the end of car design as we know it? Or rather, the beginning of something entirely new? These different aesthetics aren't just for show. They're signs of deeper changes under the skin. A revolution in car engineering is underway, one that frees designers from old constraints. Electric vehicle technology is enabling this new era. From flat skateboard chassis to software-defined interiors, it is opening possibilities that were unimaginable in the days of gas engines. The EV's skateboard chassis is central, but what is it? The skateboard chassis is a flat, self-contained platform, where the entire floor of the car is a big, flat battery pack, and the wheels have electric motors attached directly at the front and rear. All the crucial parts, the battery, motors, suspension, and electronics, sit in this slim base, like the deck of a skateboard. What's left above is basically a blank canvas. Designers call the vehicle body a top hat that sits on the skateboard. Because the skateboard contains all the driving hardware, you can put almost any style of body on top without redesigning the fundamentals. This modular approach means a company could use one common platform to build an SUV, a sedan, a pickup truck, whatever shape they dream up, just by changing the body and tweaking software. It's similar to how computer makers use the same internal components but change the outer case. For car designers, the skateboard chassis is a game changer. With a flat floor and no big engine block intruding, they are free to play with proportions and layouts that would have been impossible before. Wheels can be pushed out to the corners of the vehicle, shortening the overhangs and creating more interior space. The passenger compartment can stretch out, giving occupants unexpected roominess. Even small EVs can feel spacious inside. If you've ever sat in the back of a traditional car and had to straddle the tall hump in the floor that houses the drive shaft or exhaust tunnel, you'll appreciate that an EV's flat floor eliminates that, making a clean, open cabin design. The skateboard also lowers the center of gravity by putting the heaviest component, the battery, at the bottom. This can improve handling and stability, meaning engineers can tune the car for better ride comfort and performance without worrying about a top-heavy engine up front. And since the motors are compact and tucked away near the axles, there's no need for a bulky transmission running through the car. In practical terms, that frees up space for features like extra storage. Many electric cars even have a frunk, a front trunk where an engine would normally be. Safety can improve too. With no engine up front, designers have more freedom to create crumple zones that absorb crash energy effectively. All of these technical advantages feed directly into new design freedom. The technology invites creativity rather than limiting it. Even the skateboard chassis is seeing constant development. CATL recently announced their Bedrock chassis that has integrated battery cells directly into the chassis itself. This means either more battery cells can be fitted into the same amount of space, or the chassis can be made lower profile with the same power. Companies like Tesla and BYD have managed this too, with their latest designs bonding the cells directly into the vehicle's body structure, removing redundant supports and thus saving weight and space. A lighter car can go faster and further, improving performance, but it also has aesthetic ripple effects. Weight savings might allow a slimmer roof or less bulky pillars while still passing crash tests, potentially enabling more glass or more graceful proportions. Structural battery tech also means fewer constraints on where structural beams must go, possibly enabling features like larger door openings or panoramic roofs without heavy reinforcement. CATL's entrance into this market is particularly interesting, however, as they just make batteries for cars rather than cars themselves. Having advanced, ready-to-go chassis from a third-party manufacturer could change the development focus for car brands, and even encourage many new companies to get into the market. This would allow brands to focus on the things like technology, interior space, and entertainment above the traditional driving-first focus of the past. The aesthetic focus can shift from accommodating hardware to enhancing user experience and brand identity. In the EV era, the emphasis moves to bold design and a strong identity through shape and details, because traditional engines, and the character they imparted, are no longer a differentiator. Anyone keeping a close eye on the technology space would have probably heard the rumours about companies like Apple, Dyson, and Sony developing electric vehicles. While a lot of these projects appear to have been cancelled, some look to be making it to market, like the Sony and Honda collaboration, the Afeela 1, which had its pre-orders announced at CES 2025. This seems to make sense, as Sony is a massive manufacturer of sensors, cameras, and screens, among other technologies being utilised by many other brands and products around the world. Their partnership with Honda appears to allow Sony to focus on the modern electronic aspects while leaving the traditional car-building aspects to Honda. This makes technology companies uniquely well positioned to take on the car market as they shift away from mechanical to electronic engineering, with software becoming a far more prominent differentiator. In this new landscape, terms like software-defined vehicle have emerged to signify that so much of the car's character is determined by code rather than mechanics. How does that translate into design and driving experience? Traditional cars rely on mechanical linkages, a steering shaft, hydraulic lines for brakes, cables for throttles. In contrast, many new EVs use electronic systems to control acceleration, braking, and even steering, known as drive-by-wire, or specifically steer-by-wire for the steering system. In a steer-by-wire setup, turning the steering wheel sends an electronic signal to a motor at the wheels rather than physically turning a shaft. This might sound like a small technical tweak, but its impact on design is huge. Without a steering column that must angle down to the front axle, interior layouts become far more flexible. Designers can slim down the dashboard, since they don't have to accommodate a big steering shaft mechanism behind it. They can even design steering yokes or rectangles instead of traditional wheels, knowing the software can adjust the steering ratio dynamically, as seen in some cutting-edge EVs like the Lexus RZ, which offers a steer-by-wire yoke. In the future, steer-by-wire could allow a steering controller that retracts completely when not needed. Imagine an autonomous mode where the car's wheel folds away to give you more space. This technology also filters out vibrations and can adjust steering feel via software, meaning the car's handling character can be tuned to be sporty or relaxed at the push of a button. The absence of mechanical pedals and linkages, with brake-by-wire and electronic throttle, similarly frees up space and allows new pedal arrangements, or even the possibility of moving controls aside when using autonomous driving. Overall, by-wire technology cleans up the design, reduces clutter, and gives both engineers and interior designers more freedom to innovate. Perhaps the most interesting shift is how software can give a car multiple personalities and keep it evolving over time. In the past, once a car left the factory, its driving character was largely fixed. An enthusiast sports car stayed loud and stiff, a luxury sedan stayed plush. But many EVs can receive over-the-air updates that tweak suspension firmness, acceleration response, even add new driving modes or sound profiles. This means a car's feel isn't static. It can be both a comfy cruiser and a performance machine, depending on the software mode. Some high-end electric models, for example, have a drift mode or a track mode that dramatically changes how the car behaves, all through programming. For design, this is intriguing. The interior might feature configurable ambient lighting and display themes that change with the modes, effectively letting the aesthetic ambience shift from, say, calming blue tones for eco-driving to aggressive red accents for sport mode. We're also seeing the rise of advanced infotainment and user interface design as a core part of car design. Giant screens like the 48-inch dash display in the Byton concept car or rotating screens become centerpiece design elements. Because the car's functions are controlled through software, physical buttons are disappearing, giving cabins a cleaner, almost concept car look in production vehicles. The downside is, if overdone, interiors could become sterile or distracting, but designers are finding balances by using tactile materials and clever lighting. On the exterior, software and sensors are shaping styling too. Many EVs incorporate driver assist sensors, cameras, radars, even LiDAR units, and designers work to integrate these seamlessly, or sometimes highlight them as a tech statement. For instance, some cars use LED lighting arrays as both illumination and a form of expression, with programmed light shows or interactive signals to pedestrians. This is software-driven aesthetics. The design is no longer just metal and glass, but also dynamic and changeable elements. Other areas where advanced software looks to be prominent are aspects like self-driving and software-based safety features. Cars are moving away from just focusing on airbags, crumple zones, and structural safety features to trying to stop crashes happening in the first place. In fact, the European safety agency Euro NCAP now has a safety assistance field, incorporating electronic driver aids as part of the overall score. This includes automatic emergency braking, lane keeping assistance, and blind spot detection, which enables the computer systems to interfere with the car's movement in an emergency. Features like this will only get more prevalent as the dependence on technology increases, with a very public view from many technology-focused companies to make cars fully autonomous. None more so, in fact, than Tesla. With the We Robot event that happened in late 2024, CEO Elon Musk announced a set of new fully autonomous cars and automobiles without steering wheels or pedals, with claims that these would be rolled out in 2026. There are also companies like Waymo that are prevalent in this space, just focusing on the self-driving tech rather than the cars themselves. The skateboard chassis design may allow these tech brands like Apple, Samsung, or Google to once again enter this space as an opportunity to focus primarily on the automation software aspects. Humanoid robotics manufacturers like Boston Dynamics, Unitree, Apptronik, and UBTech may also have an advantage in this space, as a large portion of their R&D goes into getting these robots to navigate complex human environments. Sensor-based visual understanding and analysis from AIs would provide a level of parity to car-based automation. Should we get to the point where self-driving cars are uncrashable, then car design may become even less restricted, completely getting rid of crumple zones, airbags, and other safety equipment. The evidence of this design revolution is already visible, especially in the showrooms and auto shows of China. New brands and even established automakers are rolling out futuristic EVs and concept cars that break all the old design norms. Some look like they drove out of science fiction. Others reimagine the car as a smart gadget or a living space on wheels. Let's take a tour of a few eye-opening examples that signal just how far things have come. The HiFi Z, an electric luxury GT from Chinese startup Human Horizons, shows radical EV design with its cyberpunk lighting and unique door layout. This production car looks like a concept sketch come to life. It has a low-slung stance, intricate LED light strips that can display patterns and messages, and suicide doors, plus gull-wing rear doors that together create a theatrical entry for passengers. The designers weren't constrained by convention. Since the EV platform allowed a sleek floor and rear-wheel steering, the HiFi Z could incorporate features like a full-width light-up grille and even pop-out active aerodynamic wings on the back. Inside, it avoids the traditional clutter of gauges and buttons, having a driver-centric screen and a futuristic steering wheel with no mechanical column. This kind of design would have been unthinkable in an ICE-era vehicle. Too many parts would interfere, and the complexity, not to mention the cost, would be sky-high. Yet, as an EV, the HiFi Z proves that a road-legal car can look like a spaceship, complete with the performance, over 600 horsepower and advanced autonomous sensors to match its bold style. Not all radical EV designs are about looking like sci-fi machines. Some are about reinventing the car's role in everyday life. Consider the explosion of tiny, personality-filled electric cars in Asia's cities. One example is a little EV known as the Bestune Xiaoma, which looks more like a toy than a traditional car. Painted in bright colours and adorned with themes like cartoon penguins or My Little Pony, it even has an interior with multicoloured seats and a dashboard surface that you can stick Lego bricks onto for fun. This whimsical design targets young drivers and urban commuters who see their car as an extension of personal style, rather than just transportation. In a similar vein, the Wuling Hongguang Mini EV one of China's best-selling EVs, comes in a myriad of special editions with pop culture themes, convertible roofs, and vibrant paint jobs. These designs show how EVs can diversify the automotive landscape, appealing to niches and lifestyles that big gas cars rarely catered to. Meanwhile, other brands are pushing the envelope of luxury and performance design. Take Tesla's Cybertruck, for instance, an American entry but influential globally. This all-electric pickup threw out the rulebook with its angular stainless steel exoskeleton and ultra-minimalist form. No curvy sculpted body panels here, just flat steel triangles forming a wedge that's both futuristic and polarizing. The Cybertruck's design was only feasible because an EV powertrain doesn't require the usual engine bay and radiator grille. Its structure doubles as its shell, and the strength of the materials obviated the need for a traditional frame. Love it or hate it, the Cybertruck proved that an electric vehicle can radically redefine a whole segment with design alone. In Europe, Audi's Grand Sphere and other recent concept cars envision autonomous EVs as lounges on wheels, with steering wheels that retract and interiors that feel like a chic living room, made possible by steer-by-wire systems and compact drivetrains. And numerous startups have shown prototype robo-taxis shaped like pods, essentially living spaces that move, symmetrical front to back, since they don't even have a driver's seat to anchor the design. Another new trend that appears to be becoming more prevalent is customizable and modular cars. This was recently highlighted by Slate Automotive, a startup backed by Amazon's Jeff Bezos, which is supposed to provide a very basic two-seater pickup truck as a base model for around $20,000, which can then be user upgraded, converted to an SUV, or be accessorized with a range of bolt-on kits and seats. The body panels are also user interchangeable. Other weirder cars we've seen come to market are the micro-mobility style town cars like the Citroën Amy and the Micro Michelino, an ultra-small bubble car type EV with a front-mounted door and quirky retro aesthetic. This is sure to attract a few city drivers in places like London and Paris, where space is a premium and congestion and low-emission charges heavily restrict car ownership. The Citroën Amy also fits this niche, but heavily targeting the ultra-cheap, sub-$10,000 market. It features smart cost-saving features like identical front and rear panels and doors that open in different directions, meaning only one shape is needed to be made. On the other end of the spectrum, you have the Morris JE, an EV van styled in a very retro way and reminiscent of the old Morris J-type vans. Across the board, what ties these examples together is a sense of freedom and experimentation. Designers can now ask what should a car be instead of what can a car be given the mechanical limits. Some answers are strikingly beautiful, others are bizarre or playful, but all expand the vocabulary of car design. Crucially, many of these forward-thinking designs are not just wild concepts destined for museums. A lot of them are reaching production, especially in China's fast-moving market. This means consumers are being exposed to new ideas of what a car looks like and does, which in turn pressures more established automakers globally to get creative as well. The domino effect is clear. Electric tech changed the engineering, which opened up design. Daring designs captured public imagination, which now pushes the industry toward an even bolder future. All these threads, radical exterior designs, liberated interiors, software-driven experiences, weave together into a big question. What will the car of the future feel, look, and function like? If we truly are witnessing the end of car design as we know it, then what comes next? One possibility is that cars will increasingly divide into two extremes: ultra-utilitarian autonomous pods for everyday mobility, and emotionally charged, highly personalized vehicles for those who still relish driving or making a statement. On one end, imagine a small electric urban pod, a cube or capsule on wheels that's less a car and more a comfortable sofa that moves. It might not even have a front or back in the traditional sense. With all-wheel steering and sensors all around, it could dock itself in tight spots and navigate city streets while you relax or work. Such a vehicle's design might emphasize transparency, safety, and modularity. This is an extension of trends we see in concepts. It's the car as a living space, where the form is all about function and efficiency. If the car doesn't need a human driver, it could even lose the steering wheel entirely. The end of car design as we know it might literally be the end of the driver-centric layout that has defined autos for a century. Current public transport, however, has us facing the same way, with everyone looking at their phone for entertainment. Maybe car interiors will actually be beige bland spaces where we just use our mobile devices to pass the time. This is a theme companies like Tesla are moving towards, with their singular central screen, controlling all functions and serving as the only display for speed and other driving metrics. Advances in gimbal and robotics technology may eliminate the need for four wheels altogether. The recent displayed BMX-style UMV robot from the RAI Institute has shown off its ability to balance on two wheels at ultra-low speeds, or even static, and also performing a wide range of BMX and trials-type tricks. Some cars could be more like single-occupant space-saving pods, weaving through traffic while keeping the occupant perfectly level at all times. On the other extreme, consider the enthusiast or luxury segment in an electric era. Without the growl of a V8 engine to stir the soul, designers might lean even harder into visual drama and tactile feedback. Even sound becomes a design realm. Since an EV is quiet, car makers are already hiring sound designers to craft synthetic acceleration notes or futuristic hums. Tomorrow's performance car might let you download engine sounds of your choice. One day your electric supercar sounds like a starship, the next it mimics a classic Ferrari, all through the speakers. For mainstream family cars, the changes might manifest in more subtle but meaningful ways. Safety and comfort could be radically enhanced by design innovations. Cars with omnidirectional sensors might eliminate blind spots, allowing thinner pillars for better visibility. Already, companies talk about the third place concept. With home and work being first and second places, cars could become a valued third space, where you spend time comfortably or productively. So designs might incorporate mini-fridges, fold-out tables, or VR entertainment systems. Some Chinese SUVs have been shown with built-in projectors for movie nights, or built-in refrigerators for drinks. These features sound gimmicky, but they indicate a willingness to reimagine what activities a car can host when freed from driving demands and space limitations. There's a notion that the joy of driving and beauty of design will remain important. Human psychology isn't changing as fast as technology. People still love a gorgeous vehicle and the sense of freedom it provides. So while the tools and materials of design evolve, the aim of design, to delight, to solve problems, to tell a story, continues.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content.